Thank you. All right. All right, sweet. All right, so yeah, I'm Victor, and I'm a co-founder of Narwhal.io, and I want to talk to you about managing state in Angular apps. So as was mentioned, I was at Google before, where I worked in Angular. I used to blog at Savkin.com, and some time ago, Jeff Cross and I left Google to start our own company called Narwhal, where we help the Fortune 500 companies build ambitious projects with Angular. I used to blog at Savkin.com, and these days I blog at blog.narwhal.io. I used to live in San Francisco, and these days I live in Toronto, so I moved back in Toronto. That's actually one of the reasons why I left Google, because I really wanted to be in Toronto. Check out our site to see what we do and how we work. Check out our blog and Twitter to get a lot of high-quality Angular and JavaScript content. We also have 3 books, one on the Angular itself, another one is on the router, and the last one on upgrading existing AngularJS applications to Angular. All right, so the topic of managing state is very vast, yes, and we can talk about it for hours and hours. So I've thought and written about it a lot, and I tried to do my best to pick a small part of this topic, like one single slice of this problem, and cover only that part in this talk. So if you think I missed something important at the end of the talk, feel free to talk to me after, and I'll be happy to answer all your questions. So that's what we're going to cover today. Okay. First, we're going to talk about the 6 types of state a typical web application, a typical Angular application, or web application in general, has. Then I will talk about the state synchronization problems, in particular synchronizing the server and the client and the URL. Finally, I'll cover a few strategies on how we can sort of mitigate those problems, so make our applications more robust and sort of more correct. Before we dive deep into the content, I will introduce an example that I'm going to use throughout this talk. It's the same example I use in all my talks and all my articles. I like this example because it's very simple. So basically, it's an application of technical talks that you can filter, watch, and rate. It has 2 screens. The first screen shows the list of talks, and the other one, the second screen, the second route, shows an individual talk, the details of this talk. So the list view renders the talks in the filters form. And when the user types in something in the filters, the list of talks will be filtered down to match the filters. Okay? And the details view shows information about this talk, plus some actions we can do regarding it. For example, we can rate it or we can watch it. Okay? It's a very simple app, but even this simple app, and it's basically as simple as it gets, that's to do MVC, glorified, has 6 types of state. Let's go through them. So the first one is the server state. The server state is not on the client side, and surprisingly it's on the server, and it's usually provided by something like a REST endpoint or GraphQL endpoint. So it's not technically part of your Angular application, but it's important to keep it in mind and to have it in this list, because we need to deal with it when we build our front-end applications. All right? So the persistent state is a subset of the server state stored on the client sort of in memory. Naively, we can treat the persistent state as a cache of the server state. So we have a subset of the server state on the client. In reality, in most consumer applications, web applications, this doesn't work because we want to apply optimistic updates. So we want to update the persistent state first, then push an update to the server, and at some point reconcile. Right? So most applications we use day-to-day, like Gmail, Inbox, Trello, whatnot, Slack, do a lot of optimistic updates. Okay? So the items in this list is the persistent state. Yes, we got them from the server. The client state is not stored on the server. And a good example of the client state here would be the filters we the filters we use to create the list. They are stored on the client side, they're displayed to the user, but from the point of view of the server, they are sort of transparent. Yes, it receives the filters, it constructs a new list, and it sends this list to the client. So once again, the items is the persistent state, the filters we use to construct the items is the client state. It's a good practice to reflect both of those, the persistent state and the client state, in the URL. For many reasons. First, it allows bookmarking. We can save a particular state of our application and come back to it. We can send this link to our friends. And it allows for the proper back button behavior. If I click back and forward, I see what I would expect to see. Yes, if I don't reflect in the URL, that's not going to work. All right, so this means that the URL or the router state is a different type of state we need to consider. And just for information, the router state what I think of it is just a sort of a structured representation of the URL. It's exactly the same as the URL, just in a different form. Next, many applications have some state that we store on the client, but we do not store in the URL. It's not represented in the URL. And I call it the transient client state. All right? So if you watch, for example, a YouTube video, and you stopped in the middle, you went to some other site, you came back, the YouTube will start from that place, yes, where you stopped watching. So we don't see it in the URL. So if we copy the URL and send it to our friend, they'll start from the very beginning. Okay? So that's transient client state. It's not stored in the URL, but nevertheless it is there. Okay? Finally, individual components can have local UI state that governs small aspects of their behavior, like what should be the color of a button, the scrolling position, what should be selected, what should be expanded, stuff like that. Okay? That's local UI state. And it's usually derived from other types of state, but it doesn't have to be. Okay? So pretty much any web app, regardless of what technology you use, will have these 6 types of state. And the biggest problem we have with having them is synchronization. So why do we need to synchronize? We need to synchronize for the following reason, yes? Because we have multiple, or we have the same information stored in multiple places. For example, the persistent state and the server state obviously store the same items, right? So does the client state in the URL. And basically, anytime I have multiple copies of anything, we need to make sure we synchronize them properly. And the choice of our synchronization strategy or strategies will be probably one of the most important decisions you will make when starting or building your application or when architecting your application. Okay? Can we make it synchronous, for example, in certain cases? What has to be asynchronous? How do we coordinate all the things? It's very challenging and has to be done very carefully. Let's be more specific. Let's look at one problem in detail to see how hard it is to get it right. Let's talk about the synchronization of the persistent state and the server state. Let's say we have this class, backends, named very simply, that we use to interact with the server. As you can see, it has a cache of talks. And in the interest of time, I'm not going to cover how we are going to populate that cache. I'm going to omit all these details because it's a very hard problem in itself. Let's not worry about it. Let's worry about something which is smaller. Okay? We are going to look at the rate talk method instead. Okay? It is very, very simple. It takes a talk ID. It takes a rating that we'd like to set. And what we do is we find the right talk in memory. We update the talk optimistically. And so the UI will react right away. So the user can see this feedback. The application feels responsive. And after that, we're going to send a request to the server to update the same item on the server. Okay? The question here, of course, is what happens if this request fails? Yes, because obviously, this request can fail and it will fail. Every single request you make in your application to the backend will fail at some point. And so this is just the reality of it. And as you can see, we don't do anything here to handle this failure. Yes? We don't have code that actually handles this error. So what will happen is the talk object on the client side in our application will remain rated. So it will have a rating set. And the same object on the server will be unrated because an error happened. And we have this essentially an issue where the persistent state and the server state are out of sync. And our application is broken. Because what the user sees is not what actually is stored on the backend. If the user refreshes the page, the information will be different, which is a horrible state to be in. So what most developers will do, and what I used to do, is try to fix it in a very ad hoc way. Like I'm just going to throw a catch in there, and in this catch I'm going to reset the rating back to now, what it used to be. Or I'm going to store the old value somewhere and reset it to the old value. It's very simple. And that kind of works. This particular problem, it seems like it's fixed. So if an error happens, I'm going to get an error back. I'm going to reset the rating to what it used to be, and my state is synchronized again. But in reality, this doesn't actually fix the problem. So if you do fixes like that, in reality, your application is still broken. So let's see why. It is broken for the following reason. Okay? Imagine I have 2 requests coming out, going to the server. The first one sets the rating to 4. And let's say the user changed your mind and set the rating to 3. At the moment we are setting this rating to 3, the first request shouldn't matter. Yes, so the response for the first request should matter. But it might happen for a variety of reasons that the response for the first request will come last. That's not unreasonable. Nobody can guarantee the order of the response in our application, so it can come last. And maybe it is a failure. In which case, we are going to reset our rating to null on the client side in that catch block, even though it's clearly set to 3 on the backend. Okay? And again, the result is that the persistent state, what the user sees, and the server state, what's actually stored on the server, is out of sync. Our application remains broken. Yes? Most web applications suffer from stuff like that, from these problems. Pretty much every single application I look at, with pretty much every single client I work with, they have lots of problems like that, lots of issues like that. If you think that your application doesn't have them, chances are you're overconfident. That's because any web app has gazillion errors of this sort. And as you can see, ad hoc solutions that I try to apply do not really work well. We need a more holistic solution, sort of a more thought-through solution, which I'll talk about in the second part of this talk. All right, so that's the first problem. Synchronizing the server state and the persistent state is just super challenging. Yes? We try to fix it, still broken. The second problem is synchronizing the URL, or the location in the browser, and the client state. And again, most web applications you look at have some sort of issues with that. If you try to click back and forth very quickly, shit breaks all the time. So why is that? Okay? So let's look at this component to see why. Let's say we have this component. It's a very simple component responsible for showing talks at the main screen. It has a list of talks plus some filters. Has an event handler. So anytime a filter changes, we are going to refetch the talks, and just reset our cache. Seems pretty straightforward. That's what we do day to day. The problem here, of course, is that I do not store anything in the URL. Yes, so the URL is essentially empty. If I refresh the page, all the filters will be gone. The back button doesn't work. So technically, the application runs, but we would consider this application broken, because it doesn't behave like a proper web application. The URL is useless here. Okay, we cannot sell the URL to our friend. All this stuff doesn't work. Okay, so let's fix it. The most sort of obvious way to fix it again is ad hoc way. We're going to say, let's fetch some talks, from the server when the filters change. Once we get the new data, let's update the location. And one way to update the location would be to navigate to the right route, just to say, we're going to get the data, now let's represent the data in the URL. So location, the URL, has this information right now. So we're halfway there. But if I refresh the page, this information won't be picked up. Yes? I don't do anything to listen to the location, to get this information from the URL and display it to the user. Yes? So we can do another ad hoc fix. We can just say, let's listen to all changes in the URL. And anytime parameters change, what I'm going to do, I'm going to refetch data again. Okay? So on the surface, that seems like things are working. Our application is fixed. If I click on the button in the UI, what will happen is the right data will be fetched and the URL will look correctly. If I change the URL directly by, for example, clicking on the back button or just modifying the URL in place, again, I'll look at the filters. I'm going to fetch the right data and show it to the user. So it seems like everything works. Yes, but hopefully we know what's coming next. And the same issue is coming. Yes, if I change the URL very quickly back and forth, which I often do, because I have a lot of anxiety day to day. Let's say I change it from A to B. What will happen is I'll fire 2 requests. One to get talks containing A, the other one to get talks containing B. And let's say it takes time to get the data for the first request. Not unreasonable, and the response for B will come first. So the result of it would be very, very sad. Yes, we were going to have filters showing B, the letter B, but the list of talks that contains A. So our application is broken in itself, even not considering the backend. Yes, it's completely broken. Again, happens so often. Yes, that's why if you go to a banking app, you're so afraid to click back because who knows what's going to happen. Yes, the URL is always broken. You're like, I'm genuinely afraid that my money is going to go somewhere else. So it is very hard. Yes, we try to fix it and we just cannot fix it. We applied, catch blocks, we listen to changes, and that's what we tend to do day to day. If you look at most apps, most of the fixes are in this kind of done in this kind of way. And what the saddest part is that our application will probably pass unit tests and will probably pass end-to-end tests. Yeah, so if you look at the stuff, chances are if we try to test it, all the tests will be green. Okay? And this is the reason why they will be green, is that testing doesn't tend to surface race conditions unless you explicitly test for that. As if you just write unit tests to make sure your application is correct, so to speak, you're not going to see race conditions like manifest in your unit tests. And those race conditions that we just saw are the result of us not thinking carefully about how we manage state in our application, how we interact with the backend, right? And most applications suffer from it. Has nothing to do with Angular, has nothing to do with React.js. You can write it ad hoc, just DOM elements and set timeouts. We're going to have exactly the same set of problems, maybe even worse. So to be more specific, we did it wrong in the following ways. As first, we didn't separate state management and the side effects. If you look at our backend class, for example, it does everything. Yes, it talks to the server, it manages state, it can do some computation. That's not very good design. Second, we didn't clearly define the synchronization strategy of our client and our server, of the persistent state and the server state. Even after our changes with ad hoc fixes, we can see our application is broken. Yes, we can easily break it by just like clicking back and forth or go into a tunnel or taking TTC. We didn't clearly define the synchronization strategy of the client state and URL. And again, we tried to fix it. The fixes were ad hoc, and we could clearly see that it's buggy. We can clearly break our application without any problems. Finally, our model is mutable, so we update everything in place, which makes ensuring any sort of guarantees very difficult. That's not really shown in this race condition example, but to fix it properly, we need to address that as well. So let's see how we can fix it. All right. Let's start with clearly defining the state management, or clearly separating, rather, the state management of our application from the side effects. Because those two concerns are very hard to manage, so we should manage them separately. So this is what we had, what we ended up with, trying to fix our first problem in an ad hoc fashion. And it's very tricky to straighten it up, to make it right, because the backend class just does too much. It manages side effects, makes a request, updates some state, it manages state, obviously, so it does a lot of things. And we know that managing state is super difficult, excruciatingly hard. So lumping it together with anything else, like talking to the server, doing computation, logging, or whatever, will just make our lives even harder, unnecessarily difficult. And our lives are already unbearably difficult. So we shouldn't do that. We should separate them very carefully to make sure we can go through the day without tears. So there are many ways to fix it, or to provide the separation. And what I'm going to show you today is going to use NGRX, which is a library for Angular to manage state, because I'm on NGRX core team, so I'm biased towards it. But the point here is not the library. Yes? The set of ideas I'm going to talk about apply universally across libraries, across frameworks, even across platforms. So I'm not going to go into NGRX in detail because it doesn't really that important. I'll just give you a very quick overview. And if you did any Redux-like state management, you probably know how it looks like because it's essentially a Redux-like state management system. So NGRX has two core parts. The first part is the store and its reducers, and the second part is effects classes. Store and its reducers is what we do or what we use to manage state. They are responsible for managing state. So what happens in an application, components will dispatch actions indicating some sort of intent. They will dispatch action to the store, and then the store can update its state based on those actions. Very simple. Effects classes can listen to the same actions, and they can execute side effects based on those actions. Okay? For instance, they can talk to the server. With this setup, our backend class, our service, is basically a stateless service with no logic. It's very simple. It doesn't do anything. Okay? So once again, store and reducers manage state, and effects classes just execute side effects. So that's what the backend class looks like. Just a simple wrapper around the HTTP. As you can see, there's nothing going on there. In simple cases like that, we can even inline it. Yes, we don't have to have it. But it doesn't do state management anymore, and it doesn't do any computation. That's very important. Store is built of reducers, yes, which are functions that take the current state or substate of our application, a particular action and return a new state of our application. Yes? An action is basically just a simple object with a type, which is a string, and some payload, something that we need to process that action, some extra information. That's one of those reducers that our store is built of, and it handles the rate action. Okay? And it does it very simply by creating a new state object with a selected talk rated. Super simple. It finds the token in the state, creates a new copy of the talk with the right rating set, creates a new collection, and then creates the whole state. If the reducer doesn't recognize our action, we're going to return the existing state. Okay? Just for your information, because we have discriminate types in TypeScript, we actually know the type of talk inside the rate case. So TypeScript will autocomplete everything, so you don't lose any of the type safety or refactoring abilities by using a pattern like that. Okay? So note, in the setup, we no longer mutate our data. Yes? We create a new copy, yes, of the talk object, of the collection of talks, and of the whole state. And it's worth stressing this out. Yes? We want to keep a persistent state and the client state, the state that we share across components in different parts of our application, immutable. Because it is shared, yes, having it mutable is just a source of headaches. Local UI state, the private field inside your component, you can keep mutable, it doesn't matter. Yes? Those things are never the source of your issues. Okay? The shared one, something you can, two agents at the same time can look at and modify, has to be immutable for you to be able to predict what your application does. Okay? Also, like a side note, here creating a new state copy, a new state object is a bit verbose, but one can imagine putting together a simple library of 5 helpers that makes it less verbose, makes it a one-liner. Or you can use libraries like immutable.js, for example, to make it a one-liner. Okay? So now let's look at the effects class, which looks a little bit intimidating, so I will walk you through it. So this effects class is handling the rate action. So it uses the actions observable, and the RxJS observable, and that observable has sort of all the actions that are going through our application. All the actions that are happening in our application will go through that observable. Okay? So what this effects class does, it taps into it to get only rate actions. So it filters it down to a particular type of action. And for each of those actions, it makes a request. And remember, it's an optimistic update. So if our request succeeds, we don't have to do anything. Yes, we already update our client state before that. If, however, our request fails, which might happen, we are going to dispatch another action. Yes, we're going to dispatch an rate action. And here there's a little bit of NGRX syntax. Essentially, if we return an observable of actions, it's going to be piped back into the store. Essentially, we're dispatching an rate action. The most interesting part of this sort of slide of the setup is the concat map operator. And I want to show you what it does. So concat map will process all your requests in order. Okay? So it is going to wait for the response to arrive or for the observable to complete, the observable that corresponds to that request to complete before submitting the next request. Okay? We can use concat map in this fashion because we have a single observable of all rate actions. We can actually say we want to process all rates in order. So we didn't have a single observable of rate actions in our original design. So we couldn't just apply concat map. Yes? Only because we changed our design to have this long-lived observable of actions, we can actually apply concat map to synchronize, or linearize, rather, our updates. Finally, in the setup, we want to add the handling of the unrate action. Okay? And again, we take the object in memory, create a new copy, all the same kind of stuff, to create a new copy of our state. This is what it actually looks like. So we're going to, if we want to rate a talk, we're going to dispatch a rate action. It goes to the store does whatever it needs to do. At the same time, it goes to an effects class. The effects class goes to the server, tries to update it. If it succeeds, wonderful, we don't do anything. If it fails, we're going to dispatch an unrate action that will undo our state modification. Okay? In general, it's a good rule to follow that optimistic updates should always have special actions, separate actions to deal with the errors. So don't try to patch it up and update the objects in place and pretend that your application didn't fail or that update didn't happen. Because the users clearly saw that update. If it takes 5 seconds for the server to get back to you, I can see the stuff flickering, So because the users can see it, this failure, this error, the unread action has to enter the domain language of your application. We have to talk about it explicitly. And when we use NGRX or any Redux-like way of managing state, your actions is the domain language of your application. Okay? And as such, we need to add a new action. Okay, so let's look at the result of this change. So what did we get? Yes, we made this change, and the result is actually pretty nice. We separated state management and side effects. Yes, state management is done by our reducers. Side effects are done by our effects classes, are implemented by effects classes. We have a very clear undo strategy. Previously, it was ad hoc. Now we have a separate action that we know how to handle. For example, in addition to just undoing the state modification, we can also show something to the user, say, hey, unfortunately, an update failed. Try again, or whatever. Because we use concat map so elegantly in our effects class, we no longer have any race conditions. That issue is gone. Yes, our application actually behaves correctly. So everything is sort of in its place, clearly separated, and we don't have our bugs. That's pretty nice. Finally, we use NGRX here, but it wasn't our goal. It doesn't matter. It's very easy to use NGRX and still screw it up. Still use mutable state, didn't separate anything, have computation and state management and side effects in the same place. It's very easy not to handle errors properly. So, it's really up to you to make sure you do it right. Tools like NGRX or any Redux-like way of managing state just make it slightly easier or like somewhat easier, but you can still screw it up, or you can do it right without them at all. All right, so that was the first problem. Let's look at the second problem we saw and how we can address it. The second problem is synchronizing our URL and the client state. This is the component we saw. That's what we ended up having after we tried to patch it up sort of ad hoc. The first issue here that we can clearly see is that we have two ways to update our cache of talks. One via the event handler, and the other one by updating the URL. And it sucks to have two ways of doing the same thing. Yes, it's just not very good. So let's fix it. And to fix it, we're going to follow this rule, which, again, is a universal rule you should follow regardless of which framework or library or whatever you use, which is the router or the URL has to be the source of truth and the initiator of actions. In other words, the router should invoke the reducer or whatever state modifications you want to do, and not the other way around. So why is that? Yes, why do we have this rule? Because the user can always modify the URL directly. It's simple as that. Because I can click on the back button or I can change the URL in place, my application has to handle it. It has to be the supported use case. And because it has to support this use case, we might as well make it the only use case we support. Just very simple. So to fix it, we are going to change our handle filters change function to just navigate to the right URL. And then the constructor, that callback in the constructor will pick it up and will refetch the data. So application will behave correctly. If this looks reasonable, we have one place, of actually fetching the talks. That's pretty good. And but there is another issue here. And the issue is that this component knows way too much about what actually affects the list of talks we display, because it explicitly listens to params. So the information about how this list of talks is constructed is hard-coded, in this component. So we want this component to be used only for displaying data and triggering actions. We don't want it to know how the data came to be. And so what we want is something like this. Instead of actually listening to params and listening to URL, trying to figure out how to refetch the talks, we want to just say, I assume the store just has the right talks. I'm going to listen to talk changes in the store. Yes, and the store will give me an observable, and every time an array of talks changes, I'm going to get a new copy of that array, which I'm going to display. Yes? Very, very simple. So this is the series of steps we'd like to have. Yeah, the first one is the user clicks on something to filter the list of talks. The component calls router.navigate to basically update the URL. The router executes the navigation, updates location with the URL, store and effects listen to this change in the location, in the URL, store updated state. The component gets an update from the store and displays the data correctly. Okay? As you can see, like unidirectional and stuff like that, it's actually a very simple data flow. And we don't actually care if we change the URL directly or by using the UI. The data flow will remain the same. Yes, that's pretty nice. So we looked at the first two steps already in the component. Let's look at the third one. Okay, so What happens is, so in Redux, the library used for state management has an integration with the router. So every time the router navigates somewhere, it's going to dispatch an action called router navigation. So what we can do in our effects class, we can listen for that router navigation and say, every time router navigation happens, we're going to fetch the new data. It's pretty simple. And then we're going to map it into something that's meaningful. So our store can invoke its reducer and update the state in memory. Note that it's very similar to how we did side effects before, how we implement the rate action, except that instead of using the concat map operator, we're using the switch map. So why is that? The switch map is similar, or exactly the same in terms of type signature. The type of switch map is the same, but it does something slightly different. Yes? Switch map will only handle the latest value. So if you have basically a switch map is a long-lived observable of actions, it will only handle the latest value. If a new action appears, we no longer care about the previous one, which is often the case with reads. If we're going to read the same entity from the server and I read it 3 times, I care only about the latest snapshot of that entity. The one before doesn't matter. I'm not going to display it. I'm not displaying the history of entity, right? So essentially, what we want is, the moment the user types in B, we want to ignore the response for A. We don't want to wait for it. There is no point to wait. Yes, it's just like it's not important. Okay? So we can use, again, switch map in this fashion. So simply, because we have a single long-lived observable of actions. We didn't have this in our original design, and that's why it wasn't possible in our original design. It's only possible right now because we have those long-lived observables. Finally, we can update our reducer to do something like this, to just reset talks. It's very simple. And after that, once we reset the talks, the component will pick it up via this observable, and it's going to display the right list of talks. Okay? So if you look at this component right now, it looks much nicer. Yes, it does 2 things. It triggers navigations, which is pretty straightforward, and it reacts to state changes. How those navigations resulted in those state changes, we don't really care. The component doesn't really care. The component got a lot more abstract and generic. If, for example, I just receive a new update from the server that there is a new talk in the list, this component will react to this change in exactly the same way. It doesn't have to know it's a separate event that triggered that update. So the diagram roughly looks the same. As we can update our filters via the UI or via the location, it doesn't really matter. Both events will dispatch router navigation. Both will result in a fetch. Both will dispatch talks, and then our component will update what needs to be updated. Okay? So this is the result of this change. Yes, what happened is, why I think this change is nice, is that updating the location directly or via the UI right now works in exactly the same way. Yes, there is one way to do stuff, which is always better than having 2 ways. Our component is super simple. It's as simple as it gets. There is the only dispatch action, and they only react to state changes. It's very, very simple. We want components to look like that. Because we use switch map in our effects class, we no longer have race conditions regarding reads. Yeah, it's very nice as well. Our application actually behaves correctly. So everything is in place, everything is separated nicely, and all the issues we had are no longer there. Okay? So in addition to just solving this just essentially bugs, our application was broken before, so we solved those. But we actually get a sort of a cleaner design. Yes? And I think the fact that this clean design is why we don't have bugs, because we can actually think through our application with confidence. Just to give you sort of a quick overview of why it is a clean design. Yes? We have components that simply render UI. Yes, they render UI, dispatch actions, react to state changes. Super simple. Yes? And building UIs is very hard. Yes? So we want components to be as simple as possible. By following this approach, your components will not have any business logic or any coordination logic. Okay? Testing such components is very easy as well. What's interesting is that reads and writes separate as well. And over again, I see in design that when you separate reads and writes, nice things just fall out. It's a lot easier to reason through application. Separating reads and writes is a good property in general, and we got it here. Second, stores and reducers are only responsible for state management. Synchronous pure functions, very easy to think about. We can easily test them, value in, value out. It's very nice. And because we have the store as a global entity, we can model the store as a database. Have one place where we store all the state in our application. We keep of the state of our application. For example, if you like relational databases or relational algebra, you can say, I'm going to model the state of my front-end app as a relational database. That's what I do. I have lots of collections of shallow objects with foreign keys that I join. The advantage of this is that I can apply the same set of thinking, or the same set of patterns I know from the backend to my client-side apps. I can think about normalization, and all the things. If you don't like relational databases, you can always use, a more document-oriented way of modeling the state. And say, I'm actually going to have aggregates that I store in the store or keep in the store. Next, effects are responsible for doing coordination and side effects. And I think this is by far the most interesting part of NGRX, because people often when they talk about Redux or NGRX, especially Redux, they say, oh, look how simple it is. It's just a pure function, pass value in, get a value out. Oh, yeah, like your reducers are simple pure functions because they don't do anything interesting. Yes? Anything interesting is like talking to the server and doing coordination. That's where the hard part lies, And that's why I think that thinking through that part is a lot more important, yes? And in my mind, or like in my opinion, RxJS is probably the best mainstream tool you can use to model coordination and side effects, because it's built for that. It's been tried on many platforms. It works really well. So you can say, can I just use async await, and do the same? You actually cannot. The fact that observables are reified, the fact that they have notion of time defined, the fact that they can be hot and cold, have all those combinators and stuff like that, they have subscriptions, allow you to model interactions with like one line of code, 2 lines of code, and allow you to express so much with just like a very concise way. Yes. If you try to implement switch map, for example, using promises, you're going to be it's very difficult. Yes. We're still arguing if promises should be cancelable. Okay. So it's a lot easier to do with RxJS than without. All right, let's go through the summary. Basically, what we started with, at the beginning of the talk, was a simple app, and the app looked fairly reasonable. If I had this app, I saw this app, provided by my client, I'm like, yeah, it actually looks pretty good. Looks well written, functions are very small, looks well crafted. But when we look at it closer, we saw how broken it is. Had lots of problems, and many of those problems aren't easy to see if you don't have a trained eye. So we tried to fix them in an ad hoc fashion, sort of applying catch blocks, and again, that's what most people do, because that's the easiest thing to do. But turns out this ad hoc fixes didn't work. The solution wasn't holistic, and the issues actually didn't go anywhere. And again, those are not Angular or XJS issues. Anytime you build any app, yes, you have this set of issues, because any web application is a concurrent distributed system. And when you try to ad hoc patch it with a few catch blocks, you're not going to win it. Okay? It's going to be broken. So what we did, we embarked on refactoring this app. Yes, we tried to make our data mutable. We switched to NGRX to control state management a little bit more tightly. We implement a new way of modeling side effects. So we made the router a source of truth, and all the issues were gone. In addition to that, we got a lot of other things, like actually components right now are easier to test and stuff like that. The main takeaway here, though, is not that you need to use NGRX. It's like you don't have to. It's great, but you don't have to. But that you have to think very carefully about problems like that. Anytime you have a state management issue, think it through. It's a very hard problem. It requires careful thinking. Chances are your first attempt is going to be wrong. So anyone who says, just use my special library and your life will be great, is either ignorant or not honest. So nothing is going to fix it for you. It's a lot of hard work. And even then it's going to be broken a little bit here and there. So decide on the types of states you have in your application. Decide on how you want to manage them. Decide on how you want to make sure your state is consistent. So be intentional. Actually think it through. If you want to learn more, check out these 3 articles. The first one essentially is this talk just in the form of an article. The second one talks a lot about NGRX in a more abstract way on how to use it right. For example, how you can categorize actions, how you can implement complex data transformations, and things like that. Even if you don't use NGRX, check it out. I think it's useful if you use RxJS essentially. The last one talks about race conditions, and again, even if you don't use NGRX, check it out because it shows how to use marbles or marble testing to test race conditions. And if you use RxJS, you have to use marbles because otherwise you just causing yourself unnecessary suffering. Check out our blog, our site, our Twitter. check out our books. All of them are somewhat nice. One last thing before I'll be gone is that look, we're hiring, very nice. So if you want, you can join us. And if you join us, you'll help giant companies with thousands of Angular engineers, be productive, establish best practices, build their infrastructure. You'll build open source tools. You'll work on many things like engineering, speaking, flying around, stuff like that. You won't be bored, essentially. You'll work with interesting people. And we are distributed companies. We don't have to be in Toronto or in San Francisco, where we also have a lot of folks. You can be anywhere in the States or Canada. But if you're in Toronto, that's not because I'm in Toronto. So please be in Toronto. I'm tired of being lonely. And also, we pay a lot. Okay, so if you want money, that's a good place to be. We're looking for experienced Angular engineers. If you are an experienced Angular engineer who worked on large projects, reach out. Consulting experience is a plus, but not a requirement. Open source contributions are a big plus, but not a requirement. Thank you.